Hello everyone. In this video, we will see how to evaluate this kind of integral by using the method of partial fraction. How do we know that first of all that we have to use partial fraction? Thing is that when you solve this, try to solve this integral, like if you suppose multiply this x inside, so you'll get x squared plus 2x. So you'll see that the none of the methods that we studied so far, like integration by substitution, integration by parts, or direct integration will work here. So in this case, we have to use the method of partial fraction. So for that, you need to remember these rules. Like if you have the linear factors, product of two linear factors, then you can write it as a partial fraction of a over ax plus b. That is first linear factor plus b over the second linear factor. Okay. So for instance, if you have say x over x plus 1, x plus 2. So what you will be doing, you can write it as a over x plus 1 plus b over x plus 2. Why I am calling it as a linear factor? What do we mean by it? If you look at the power of x, it's only 1. Okay, so using this rule, this is the first thing that you have to do. Rest of the steps we will see later. Now, other possibility is one of the linear factor appear twice. See, it's repeating twice. So what you will do? You write that first linear factor a over the first linear factor, b over power 1 of the linear factor, and then c over power 2. Okay, you need to remember these things. The third one is the possibility that you have a quadratic factor. When you have a quadratic factor, you will be writing two constants and one of the constant with x. For instance, if you have say x over x squared plus 1 and x plus 2. So in this case, x squared plus 1. So it means it's quadratic factor. You will be using two constants. One with a variable x. And for the linear factor, you will be writing c over x plus 2. This is how you work. So you need to remember this. So let's see how we are going to work on this. So they may ask you a question in this form or this form. So what we did here is like we just write x square plus 2x in terms of factors like x, x plus 2 so that we can apply the method of partial fraction. So what we are going to do here is, let's write down this term first. X plus 1 over x, x plus 2. By using the case 1, it will be a over x, b over x plus 2. Okay, this is the first step. Now what we have to do is find the value of a and b. So for that, first we will add these two numbers. We add them as we add two rational numbers, like if you have 1 over 3 plus 1 over 2. How you will add? You find the greatest common factor and then cross multiply. Like this is 2 plus 3. Same way. So as we are saying that this is equal to x plus 1 over x, x plus 2. So we write here the denominator as same, x, x plus 2. Okay. Now we have to look at what will come with a and what will come with b. Okay, there are multiple ways of doing this. Like you can cross multiply, let factors come here, or otherwise the easiest way that work for all the cases is you multiply this entire with this denominator, say x, x plus 2. So when you multiply this with x, what happened? With a, sorry. This x and x get cancelled and you left with only x plus 2. Okay, when you multiply this with b, what happened? X plus 2 get cancelled and you left with only x. This is the easiest way of doing this. Okay. Now, we say that these two sides are equal. So it means denominators are same. We can cancel them. So it's same as saying that x plus 1 is equal to a times x plus 2 plus b times x. Now what we want to do here is to find the value of A and B. Again, there are many ways of doing it. Let's go for the easiest one. So what we will do, we have to find two constants. So we substitute two different values of x in this equation. Okay. So how do we get those two values? We get these values from the denominator of the question. So one is, say you write x equal 0 from here. Okay. And the other value you will get by x plus 2 equals 0. That gives you x equal minus 2. So we are going to use these two values. So what we get here? When x is equal to 0, so left side. Remember, you have to replace all x's on both sides. Okay, you will be changing this x as well as this x. Okay, so this gives you 0 plus 1 on the left side equal a, 0 plus 2 plus b times 0. b times 0 becomes 0. So 1 equal to a. Dividing both sides by 2, this cancels, gives you a equal half. Okay, so this is the value of a. Similarly, to find the value of b, we use x equal to minus 2 in this equation. This gives us minus 2 plus 1 equal a times minus 2 plus 2 plus b times minus 2. Minus 2 plus 2 cancels, so a cancel. So this gives you minus 1 equal minus 2b. Dividing both sides by minus 2, cancelling this, gives you b equal half. So now once we get the value of a and b, we use it at the very first place where we introduced a and b. So this gives us x plus 1 over x plus 2 equal a, which is half x plus b, again half over x plus 2. So now evaluating this integral dx is same as finding the value of this integral plus this integral. Okay, so now our things become easy. So this is now half integral of dx over x plus half integral of 1 over x plus 2 dx. So this gives you half ln of mod x plus half ln of mod x plus 2. Since this is indefinite integral, we add the constant of integration c and we get our answer. Let us see another equation. So in this question, what you see, one of the fraction is vector is linear, another is quadratic because x power 2. So in this case, how we will write the partial fraction? 2x plus 1 over x plus 1, x square plus 2. So for linear, we write a, x plus 1. For quadratic, x square plus 2. We write bx plus c. Okay. Let me make this change in place of 2 to let's say 4. Okay. The process will be same. So again, we will do the same thing. We will simplify it to get the values of a, b and c. Okay. So how it will be done? So again, we are comparing 2x plus 1 over x plus 1, x square plus 4, this. So the denominator will be same, x plus 1, x square plus 4. We have to find out what we will multiply with a and what we will multiply with bx plus c. Okay. So again, doing in the same way, with a, you will have, say if you multiply this entire with x plus 1, x square plus 4. So with a, x plus 1 get cancelled. So you have x square plus 4. and with B we will have x plus 1. Now see here, there is a high chance of making one mistake, and which is very important, like you should not make that. So when you write it in this way, it seems that C is multiplied only with x plus 1, which is not the case. Your entire term bx plus c should be multiplied with x plus 1. So always keep this in a bracket. Okay. So this gives you, pairing the numerators, 2x plus 1 equal a times x squared plus 4 plus bx plus c times x plus 1. Now we will do the same thing. As we have to find the value of three constants, we will use three different values of x. And similar to previous case, let's get the value from here. So if you look at here, you get x plus 1 equal to 0. That gives you x equal minus 1. This value you get easily from here. But if you do the same thing with the second term, like if you try to put x square plus 4 equal to 0, you will get the value as plus minus of root of minus 4, which is not real number. So we will not use this. What we will do instead, since we need two more values, we select two values different from this on our own. Up to you. So to make the things easier, you may go with x equal to 0 and x equal to 1. But again, I'm saying you can use any values different than this. I'm using this because it will make the things easy. So let's see, when we replace x by 1, what happened? Again, you have to replace both sides, left as well as right side. On right side, three places. So this gives you 2 times minus 1 plus 1 equal a times minus 1 square plus 4 plus minus b plus c, because b times minus 1, minus 1 plus 1. So see carefully, minus 1 plus 1, this becomes 0. 0 multiply anything, this entire term becomes 0. Okay, minus 1 to the power 2 become plus 1. So 1 plus 4, this gives you 5a. And on the left side, this is minus 2 plus 1 gives you minus 1. Dividing both sides by 5 gives you a equal minus 1 over 5. Okay, now two more values. So let's say x equal to 0. Start with 0. It's the easiest one. Okay, so when you replace x equal to 0 here, what you will get? 2 times 0, that is 0 plus 1 equal a times 0 plus 4 plus, if we just don't miss this, plus b times 0 plus c, 0 plus 1. So b times 0 becomes 0. So this becomes 0. You have 1 equal a. What is the value of a? Minus 1 over 5. 1 times 4. Plus here you left only with c. C times 1. So can you find c from here? Yes. So important thing is to use the value of a that we obtained in the previous step. Okay, here. So you can simplify and get the value of c as 1 plus 4 over 5. That is 9 over 8. Okay. Now to get the value of b, let's substitute x is equal to 1 in the same equation. This is your key equation. So when you replace x by 1, you will get 2 plus 1 equal a times 1 plus 4 plus b plus c and 1 plus 1. Okay, so when you simplify, this is equal to 3 equal, this is 5a, again 5a. So it is minus 1 over 5, here 5. Okay, plus this gives you 2 and then you have the value of C from here. Use this. That gives you B plus 9 over 5 into 2. Note that you have to multiply this 2 with both the terms. Okay. Simplifying all this, you will get the value of B. So this gives you, when you simplify, 2B is equal to 2 over 5, which in turn gives you the value of B as 1 over. So now you have all A, B and C. Substitute them at the first place where you introduce them. This gives you. So the key is to integrate this. Here, same as integration of these two terms. So first term you can integrate directly. That gives you ln of mod of x plus 1 with the coefficient minus 1 over 5. The key idea here. So as you see here minus in between, so you'll see either minus or plus. What you are going to do is, sorry, it's plus here. So what you are going to do is split it into two parts. So you'll have integral 1 over 5, integral of x over x squared plus 4 dx, and the other place you'll have 9 over 5 integral dx over x squared plus. So for the second integral, for this integral, you will use the rule integral of dx over x squared plus a squared. That is 1 over a tan inverse of x over a. So this gives you 9 over 5. 4 you can write it as 2 square. So 1 over 2 tan inverse of x over 2. This is the value of this integral. Okay. And for this integral, you have to use substitution. How do you know substitution? Because this is, if you use u equal to x squared plus 4, the derivative du over dx is 2x, which is available here. X is there. So when you use the method of substitution, you will get the value of integral as 1 over 5 times 1 over 2 ln of mod of x squared plus 4 for this. Okay. So your final answer for this integral will be, I'm writing it over here, minus 1 over 5 ln of x plus 1 plus, this is 5 times 2, 10, 1 over 10 ln of mod of x squared plus 4 plus 9 over 10 tan inverse of x over 2 plus c. So this will be your answer. Okay, I hope it's clear.